All right, good morning, everybody. Here's your last lesson of Chapter 5, last lesson of Quarter 3. We are just finishing out 5.6 today. And like I had said, you're not going to have a Chapter 5 test, but you'll have just a small assessment on 5.5, 5.6 this week to close out the quarter. Okay? So U substitution is the reversal of the chain rule. We saw examples that were exact matches last week, as well as examples that were off by just a constant, so we could multiply or divide by a number to make it match up. Think of these as puzzles. You have to find every single term, you have to find something that you can replace it with respect to U. So you always start by finding the inside function, and in this case it's x to the fifth plus x squared, and you name that U. Okay? You derive it. Okay, take a look back at the original, and that's exactly what we have left. So now we have the integral of 1 over u cubed du. And you can't integrate from this place, right? You always have to rewrite exponents in the denominator to negative exponents, or radicals to rational exponents. Once you're here, now we can use reverse power rule. So u to the negative second divided by negative 2 plus c. Final step is just replace u. Okay? So that was an example where everything matched up perfectly. Just a refresher on the notes. They're here again if you need them. And now let's take a look at this example. Okay, so u is given to us. We would have picked it anyway. It's what's inside of the square root. So we derive, we get a 4 dx. Okay, I don't need this 4, right? I need to find something for the dx, and then I have this extra x here. This is the third level of substitution method problems. So the first thing I'm going to deal with, well, let me just isolate my dx. So 1/4 du is dx. So we have u, and we have something going in for the dx. So I'll write this as u to the 1/2, and then I'm going to put this as 1/4 du, replacing the dx. But what do I put here for the x term? So I can't make anything else up, but what I can do is manipulate what I already have. So I said that u was equal to 4x minus 1. So I can take that relationship and I can solve it for x now. So I would add 1, and I can divide by 4. And that's what's going to go in right there. Okay. Okay. So I have to clean this integral up before I can actually antiderive it, which means that I need to multiply everything out, combine my like terms. So let me clean it up a little bit. So I have a u minus 1 multiplied by a u to the 1/2, and I have a du. I took the 1/4 and I can put them together as a 1/16. I can even put them on the outside of the integral if I wanted to. The last thing I have to do is I need to distribute into these parentheses. So adding exponents, u to the first, u to the 1/2 would be u to the 3/2. And I have u to the 1/2. Now again, this 1/16, distribute it, leave it, take it out, that's up to you. I'm going to take it out. Okay. So now I have two terms reverse power rule. So u to the 5/2 divide by 5/2 minus u to the 3/2 divide by 3/2 plus c. And that whole thing was being multiplied by 1/16. Okay? Final answer, replace u with 4x minus 1. You could distribute the 1/16 at the end, and if you had kept the 1/16 in the integral, that's the answer that you would have gotten, or you could leave it out in front. It doesn't matter to me. Here's another one that's identical to the problem we just did. So let's go through this one as well. So my inside is under the square root. I derive that. I take a look at what do I need. I need an x and I need a dx. So then I divide by 5. Okay. I need the x, so I take u equaling 5x plus 1 and I solve. So u minus 1 over 5 is x. So my three pieces get replaced with u's, and then I have to combine all of them. So I'm really focusing to clean that up together, and the fifths can go together. So it gives me a 1/25 out in front. And if I distribute the u to the 1/2 to the u minus 1, I get u to the 3/2 minus u to the 1/2 du. Reverse power rule. And replace your u. So again, this is an example where there is an extra x that we have to manipulate our u equation to find. So we're just going to look at a couple more examples, and that's really the end of the chapter for you guys. All right, so inside, 3x plus 8. Derivative, 3dx. Okay, I don't have a 3, I have an x, and I have a dx. So I divide by 3 to solve for my dx. So that's going in, u's going in, and I need to solve for my x. So x is equal to u minus 8 divided by 3. Okay, so same idea. Now I have to multiply those together and the 3's together. So 1/9 can be pulled out. U to the 12th minus 8u to the 11th du. So 1/13 u to the 13th minus 8/12 u to the 12th plus c. Griff, come downstairs, honey. Let's see. Okay, that's your final answer there. All right, I'm going to take a 30-second pause, get this question written down, and then we'll do this one. Finish my video now, okay? Alright, back. Alright, so pick the inside, x cubed plus 1. Derive it. 3x squared dx. Now, this is the trickiest one that we've done so far. This will be the hardest one that you'll see. Taking a look at what we have, again, we need to replace a dx. Okay, so let's do that. Let's isolate dx like we've been doing. And let's plug everything in that we have at this point. Okay, I'm just going to keep the x to the 5th for now. So we have an x to the 5th, we have a u to the 1/2, and we have a du divided by 3x squared. I'm doing it this way because this will help us see what do we still need. So look for things that you can simplify. Well, we've got x terms that I can divide. Right? Isn't this the same as saying x to the 5th division of 3x squared over here? Because multiplication and division is cumulative. Right? And if I write it like this, then I have x to the 5th over x squared, I have an x cubed. I have a 1/3, but that can come out. U to the 1/2 and a du. So doing it this way helps me see what exactly do I need. Well, the only x term that's left is an x cubed. And remember I said you have to use what you started with to manipulate it. So luckily, u is equal to x cubed plus 1. So I can say that x cubed is equal to u minus 1. Okay, so we've replaced everything. Now we just have to distribute and then antiderive. So we have u to the 3/2 minus u to the 1/2 and a du. So u to the 5/2 divide by 5/2 minus u to the 3/2 divide by 3/2 plus c. cubed plus 1 Okay, so let me just recap this problem one more time. So we picked our inside, x cubed plus 1. We derived it. That brought us to 3x squared dx. I chose to isolate my dx and replace. So that brought me here. So I kept the x to the fifth for now. I rewrote the square root in terms of u, and I rewrote the dx in terms of du. Then I said, well, how can I simplify this? So the x to the fifth divided by 3x squared can really simplify to an x cubed over 3. That helps me see that I still just need an x cubed. I found an x cubed in my u equals equation. So I solved for x cubed. X cubed is equal to u minus 1. Then I plugged that in, distributed, and finally got to a place where I could antiderive. And my final answer brought me to here. Okay. So I'm going to be posting in the next day or so a review / quiz for this section. It'll be a combination. Really, we're running out of time, and Friday is meant to be some sort of a reading day, so I'll post something interesting there. But finish out these notes, finish out the worksheet that I posted last week. That'll be the grade for this section. And then, like I said, look for something on Wednesday that will count as the assessment for 5.5